Okay, let's start with a ray. And let's say that this ray has its end point at point A and goes in the B direction. Now this time I'm going to draw another ray that has the same end point as A, but it's not going to necessarily be the opposite ray. Just another ray that's pointing in a different direction, but it shares the end point with the first ray. So when you draw two rays like this, you form what we call an angle. Okay? And this is called angle CAB. Now when you write down the angle, you want to make sure that you get that middle point in the middle. You could also call it angle BAC, but notice in both of these I have this point in the middle. This point is called the vertex of the angle. And these two rays are called the sides of the angle. So every angle has one vertex and two sides. Now, when you measure a segment, you measure it with a ruler or a line, a number line. But when you measure an angle, you measure it with a protractor. And a protractor is divided into degrees. If you think of a circle has a total of 180, a circle has a total of 360 degrees. So the angle here is just a piece of that whole circle. If I lay my protractor down on top of this angle, I'll be able to measure how big it is. Now the most important point on a protractor is this point right here. You want to make sure that when you buy a protractor, you take a look at it. Sometimes this point is down at the bottom, but you see, I see the number 0 and 180 on this side, and 0 and 180 on this side. So this is like the bottom of this protractor. They've put this ruler down here underneath it, but there, right there, is where the vertex goes. So I'm going to put the vertex of my angle right at that point, and then I'm going to run that one side right along so that it's right at an angle of 0. Then I'm going to read up 10, 20, 30, 40, 45, 46, 47. It's hitting this protractor at right about 47 degrees. So this angle is a 47-degree angle. Now the most common mistake that people make is they look at the wrong set of numbers. I have another set of numbers here, 180, 170, 160, 150. And so if I looked at that, it would be about 130 something, 133 degrees. That would obviously be incorrect. If I was measuring an angle that was pointing this direction, then I would use that set of numbers. So you want to make sure you're using the correct set of numbers. If you're going counterclockwise, you have one set of numbers. If it's an angle that's going clockwise, you have a whole different set of numbers. So, once you measure an angle, then we have a new notation. If we put an M in front of our angle symbol, we would say the measure of angle CAB is 47 degrees. So just like with segments, there's a difference between what a segment is and how long the segment is. There's a difference between an angle and how large the angle is, its measure. Okay? If I don't put an M in front of it, I'm talking about the angle itself, the two rays that form the angle. But if I put an M in front of it, then I'm talking about the measure of the angle. Now this particular angle was 47 degrees, and it's an example of what we call an acute angle. So here comes some more terminology for you. An acute angle is an angle whose measure is less than 90 degrees. Acute means less than 90 degrees. So our example looked about like that. If it's equal to 90 degrees, that's called a right angle. A right angle has a measure equal to 90 degrees. So that's a right angle, okay? A quarter of a circle. And when it's a right angle, we'll usually put a little square in there to help us remember that that's a 90-degree angle. An obtuse angle has a measure greater than 90 degrees. So here's one side. If I start opening it up, when I get that big, that's 90. And then if I make it even bigger, there's an angle that's more than 90 degrees. That's an obtuse angle. And then we have what we call a straight angle. And that's when it's equal to 180 degrees. In other words, one side of the angle and the other side of the angle are just opposite rays. So that's a 180-degree angle, or what we call a straight angle. Now, I want to remind you that when we were looking at line segments, we said that if point B is in between points A and C, then we had a postulate that said that this distance plus this distance is equal to the big distance. Well, for angles, we have a very similar postulate. It says if B is in the interior of angle ACD, so let me draw this picture. Angle ACD, that means C is the vertex. A is on one side, C is the vertex, D is on the other side. There's angle ACD. And B is on the interior. See, all these points in here are inside the angle. All these points out here are outside the angle. So B is any old point on the interior of that angle. Then it says, look at the measure of angle ACB. ACB. That would be that angle. This angle right here is angle ACB. And if you add to that BCD, BCD, that would be this piece. It should be obvious, because it's a postulate, that if you add that angle and that angle together, what you get is angle ACD, the measure of angle ACD. So it's very similar to what we did with line segments. This distance plus this distance is this distance. Well, that little angle plus that little angle is equal to that big angle.